And today I'm going to show you how you can tell what day a date falls on without looking at the calendar. So this technique is useful even in the edge of OK Google. And I started learning this when I was working in a lab and we have gloves on and things were everywhere. And I just wanted to find out where to collect my sample, and I didn't have access to calendar or mobile phone that easily without removing the gloves and stuff. So yeah, that's how I learned the system, and it works also as a party trick. So without further delay, let's get started. Okay, so this will be a three-part video. So I'll show you the part one, and we'll make it more and more complicated and generalized as we go on. So overview. First, I'll talk about the foundation and what the codes are and what to do in general as an overview. And then the first part, which is this video, will show you how to predict a day for a small number of years, sorry, like 2 or 3 years or so. Then we're going to generalize that for 28 years. And that's the reason why it is 28 years, because there is a cycle beginning 28 years, right? And then part three will be even further and show how the system can work for nearly 200 years. So from 1906 to 2100. So very beyond practical reasons, but it works. So I'll show you that. And as we go into part two and three particularly, there'll be more and more data analysis. So I'll talk about how I figure out the pattern, which is every 28 years, using Excel. And then part three, particularly 200 years, that's a lot for Excel. So I use the system called R. It's a programming language. And I wrote a script to test every date according to the R algorithm as well as the real date, and it works. So that's going to be more complicated. And yes, you have to learn some math, or you already know basic math, such as addition and subtractions, maybe division, but nothing complicated like algebra or calculus or trigonometry. But arithmetic is very useful. Okay, so let's go with the general structure. So basically, you will have codes for each day of the month itself, and a year. And then you add them together, and that's simple arithmetic. And then you will do some another further trick, and then you have one answer. And then you have to decode that number to get your actual weekday. So I'll talk more about the codes for a day. So for example, what's the code for 14th of April, right? So 14th is the day, and luckily the code is the day itself. So for 14th of April, the day code is 14th or 14. Okay. And the next one is the month. Now here things get a little bit complicated because you have to remember 12 different codes, but I'll help you out using some tricks I learned. So you have January, so that the code number is 1. And the way I remember that is January is the first month of a year, so that's why it's 1. February is 4 because February has 29 days in a leap year, which occurs every 4 years, so that's why it's 4. March, which sounds like a Mars chocolate bar, and the Mars has 4 letters, so that's why it's 4. April is the month of Easter, the festival, and Easter eggs are so delicious. They're round, so therefore the code is 0. May, this is a bit complicated. I remember it by saying, may I take 2 giant steps? This was a game, a game back in the day, 1900 or something, I don't know. But I read about it. Or you can remember as May Day, or May the Force be with you, which is Star Wars, 2 words, whatever works for you. So June and July will go together. So June is the 6th month, and July is the 7th, right? So people usually retire at the age of 65 or 70. So 65, the 6th is the June, and the code is 5. So 65, 5th is the code for it. And same for July as well. So 70, 7th is July, the code is 0, right? See, August is the month of astrological sign Leo. So I have a couple of friends who are Leo, so I remember it that way. And Leo has 3 letters, so August has 3. September, that has 6 consonants. So S, P, T, M, B, and R. So that's why it's 6. You can figure out other way of remembering September at being 6. So October is 1, and oct in the beginning means 8, and then you remove number of days in a week, which is 7. So 8 minus 1 equals, sorry, 8 minus 7 equals to 1. So the code is 1. And November is the same logic. 11 is the 11th month, and you remove 7, and the answer is 4. So December is the Christmas, right? Everyone loves Christmas. There's the birthday of Jesus Christ, and the Christ has 6 letters, so December has 6. I tend to remember September and December also being the long name, so that's why it's 6 as well. Whatever works for you guys, you just have to practice and remember this month. The good news is that the month code did not change even for 200 years. So once you learn it, it's going to be there for a long time. Okay, now the next one is codes for year. And this was given to me from a website back in the day, but then I extended that. So every year or Christmas or something, I'll figure out the code for next year based on when the 1st of January is. So 2013 to 17, that's when I was doing my PhD. So the codes I remember was 2013 being first year of my PhD. So the code is 1, and 2014 second, third, and fourth, so on. But 2016 was a leap year. So the code for 2017 was 6, not 5. But now we are going into the future. So 2018 is 0. 2019 is 1, 2, and because 2020 is a leap year, 2021, the code for that will be 4, not 3. So you just have to learn this using some tricks. I don't have a trick for 2018 at the moment because I figure out an equation which just tells me the code. So stay tuned for part 2 and 3 if you don't want to remember the codes, but we just want to learn the equation. And it's very simple. Okay, and there is one little trick here, guys. Every leap year, that's pain in the ass, all right? So you have to add a little bit, you have to modify the system just a little bit. Because you have February has 29 days, there is 1 extra day and you have to account for it. And to do that is to add 1 to the code of each month if the month is after February, because we're gonna accommodate for the 29, the extra day every leap year. So that's one little trick there. So hope you remember all the numbers, practice it, pause the video, practice, test, go on. And then when I was learning it, when I was walking to a grocery shop or train station, I will just remember and just rehearse the codes for the months and years and so on. It takes about 2-3 minutes, but it's very important to practice, right? And as I said, the code for months do not change, so that's very useful. So let's try a couple of one more. Now one more thing. So once you have the answer, which I'll show you in a minute, how do you decode that to a weekday? So if the answer is 1, it's Sunday, and so on. And the way I remember that is the US has the first day of the week is Sunday, which is quite weird because the rest of the world, first day is actually Monday. So if you're American, easy for you. Just say first day of the week is Sunday. That's why 1 is Sunday. If you're not from America, just say Americans are weird. They make first day of the week is Sunday. So that's why it's 1. And it goes in a sequential order. So it's not too difficult. Just remember that Saturday is 0 or 6. Or sorry, 7. So that's the thing. It goes in sequential order, not a problem. Okay, so let's try some example. 4th of July, 2018. That's the Independence Day of Americans. Right, so let's get the codes together. So 4th is a day. The code itself is 4. Now the code for July, if you recall, the age of retire is 65 or 70. So 7 is July. The code for July will be 0 because it's 70, age of retiring. And from the previous table, the code for 2018 is 0. So let's sum it up. Answer is 4. Easy. All right. Now, once you have the answer, you have to remove all the 7s out of it. So you have to, or other words, you have to take the remainder of the sum divided by 7. So remember school, you wanted to divide 4 by 7, right? So you can't really divide that. So you put 0 on the top. So then next step will be 7 times 0, which you then remove. But in that case, it's a 0. And the remainder is 4. So this is an easy example, but Next slide will be a little bit complicated. So that's what the 4 comes in as a remainder, or the take 7s out. Okay, so now if we go back, that's your answer. 4 is the final decoding key, right? We need to convert that into weekday now. If we go back, 4, so that's Wednesday. So that's your answer. Now let's confirm that using OK Google. What day is 4th of July 2018?
The 4th of July 2018 falls on a Wednesday.
There we go. System works. Okay, next example. 25th December 2019. So you can start planning your vacation next year. Okay, let's add the codes together. So 25, that's the code for 25th. December is the birthday of Jesus Christ, Christmas, sorry. So Christ has 6 letters, so the code is 6. And the year 2019 has code of 1, right? So when you add them together, it's 32. Now, you need to take all the 7s out of it. So 32, you can take 7 4 times. So 7 times 4, 28. That's the highest amount you can go. 7 times 5 will be 35. The answer will be negative. So 7 times 4, 28. That's it. So, and then you remove, then you do 32 minus 28. The answer is 4. So again, which is Wednesday. I just want to talk about that division remainder stuff here. So mathematically, 32 minus 28, 4. You take the bottom 4, not the top one. Okay, you get the point. All right, forgot to validate that part. Not this. Okay, Google. What day is 25th December 2019?
The 25th of December 2019 falls on a Wednesday.
Okay, system works again. All right, the last one, that's a little bit complicated because it has a leap year in it. So 14th of March 2020. So this is Einstein's birthday. He was born on 14th of March. Okay, so let's add the codes together. 14th plus March, which sounds like a Mars bar, chocolate bar, and which has 4 letters, so it's 4. And the code for 2020 from the table is 2. So the sum is 20, right? But not so easy, not so quick. 2020 is a leap year, and you need to add 1 to the month code if it is happening after February. Since March is after February, you have to add 1 to the answer. So the now answer becomes 21. Just to clarify, if it is 14th of February, you do not need to add 1. It's only months after February. Okay, back to the example. So the final answer code was 21, and we need to take all the 7s out. So that's easy because 7 times 3 is 21, and remove 21 from 21, and answer is 0. Now let's confirm. Let's decode that. So 0 is the day for Saturday, and let's confirm by OK Google. What day is 14th of March 2020? Right, sorry, I have 2 of the speakers, so the other one responded, not this one. But the answer is Saturday. You can check it out on a website or something. So that's it. That's the system. This is the part 1, which will work for a couple of years. And the reason is that you have to remember codes for a couple of years. And next part 2 and 3, I'll give you an equation to kind of predict the code for each year. And yeah, and hopefully you can use it for good purpose and impress people. Thank you again. Let me know how it works out for you. And please put any comments or questions or things I can do better or clarify for the next round as well. Thank you. Bye.